This figure shows us a big system including high-speed train and catenary for power supply and traction power supply system and high-speed railway bridge tunnel subgrade and the relationship between the wheel and the rail, also including the ballastless track and turnout. So when the train running on the rail lines, the S wave, that means the earthquake will when the earthquake happened, there will be a great influence for the safety of the train. So we should also consider the influence of the S wave from the earthquake and the environment consideration. For example, the temperature variation, the rain and the water influence for the system, and the wind influences on the system. So for this dynamic system, we can evaluate the stability, comfortability, reliability, and safety of the system. This is a very complex system. There are several aspects to describe this complexity. For example, for the scale effect, we can consider a few millimeters to hundreds of meters. For example, the deformation of the ballastless track, only a few millimeters, and the length of the bridge, several hundreds meters. So for the time effect, because the railway line will service life of railway line will be several decades, for example from 20 to 100 years service cycle, and the special effect because the train will travel thousands of kilometers, so it is very complex. And there are many nonlinear and stochastic factors of train system, including the nonlinear geometrical relationship between wheel and rail, nonlinear grip force of wheel-rail contact, and nonlinear characteristic of suspension system. Another big part is the randomness of system and the time-varying factors of external disturbance. For example, the random disturbance of route irregularity, the influence of earthquake, wind, rain, temperature, subsidence, and other external disturbance for the operation of the high-speed railway. The third part is the randomness and time-varying factors of structural parameters. For example, the train mice, because the passengers will come in and out the carriage, so the mice of the train will be changed, and the elastic modulus of material. And for example, the strength of the materials will decrease when the service time increase, and the elastic modulus of the materials will also be changed during special environment. In some very cold region, the freeze cycle damage will cause the decrease of the elastic modulus of the material. And the third part is structural damage. Sometimes some original damage exists in the system, or the damage will increase during operation.